So, welcome everybody. This is nice to see so many people on the um, almost last hours before a long weekend. So, really appreciate all of you being here. As you know, this is a listening session for from the IRPIC point of view, where we are looking forward to feedback from you regarding what you think the priorities for the upcoming science plan should be. Now, so what I'll be doing is I'll be giving you the high-level picture of IRPIC, talk about the general things that we're looking for feedback from you, and then Richard Caleta will talk more about the modeling perspective and where we are with respect to modeling priorities. And so we're looking for feedback across the whole thing. So to start off with, IRPIC is the Interagency Arctic Research Policy Committee. And if you count the number of logos around, there are 14 of them. These are the 14 agencies that helped in the writing of the current IRPIC plan that's in there. Going into and right now, there have been more agencies that have joined us. And so now there are 17 agencies who are part of IRPIC. And the overarching focus of IRPIC is to enhance both the scientific monitoring of and research on local, regional, and global environmental issues in the Arctic. So if you go on to the next slide, you can see that IRPIC is a prominent part of the executive branch of the government. It is a committee that is part of the Office of Science and Technology Policy and is a part of the Committee of Environment, Natural Resources, and Sustainability. IRPIC became a part of the executive branch in 2011, and it is located in the Eisenhower Executive Building in DC. So next slide, please. So this slide kind of shows the top part, which shows that IRPIC is composed of a federal government committee, as well as the bottom part that constitutes both the federal and the non-federal platform. So with respect to the federal government, there are 16 principals from 16 agencies who are part of that committee, while the open platform consists of anyone who is interested in participating and working on Arctic issues. So if you look at the IRPIC science plan, there are 9 goals, and those 9 goals are indicated in those squares at the bottom of the iceberg. And then you have, if you look for modeling, modeling is actually part of an environmental intelligence collaboration team. So there are 9 goals, and each of those 9 goals have 9 corresponding collaboration teams where the federal and the and anyone interested in topics in the Arctic can engage. And as part of environmental intelligence, we have the modeling sub-team, the observing sub-team, and the data sub-team. So that is the general structure in which IRPIC has implemented the current plan. So this is something to keep in mind to frame where we are right now and where we would like to go into the future. So right now, as part of the collaboration teams, there are over 2,000 members, and you have, as I mentioned, the people from the federal sector, from universities, from the non-governmental, industry, indigenous people, and international organizations as a whole. If we go on to the next slide, you do see, again, what you see on the right is a schematic. It's a different way of looking at it. Around the circle, you see the 8 goals, and environmental intelligence is in the center, meant to connect with all the other goals. Environmental intelligence, as a reminder, has the modeling sub-team as a part of it. Modeling data and observations are a part of it. And the IRPIC plan has 4 policy drivers. So the policy drivers set the overarching stage or the framework in which IRPIC operates. So the policy drivers indicated in the schematic go from the center to the outer ring. There are 4 of them, and the first one is enhancing the well-being of Arctic residents. The second one focuses on stewardship, that is advancing stewardship in the Arctic environment. The third one on security focuses on national and regional security. And the one in the outermost circumference is the one that focuses on understanding Arctic as a component of the global Earth. So if you think about modeling, and if you think about the way the performance elements have been focused in on modeling and the way we worked as a modeling team, we have been contributing towards the 4th policy driver, which is to improve understanding of the Arctic as a component of global Earth. That's the primary one that we've contributed to. And I did mention that there are 9 goals and 9 collaboration teams. And in each one of these goals, you have different performance elements that we respond to as part of this science plan. And that's the structure of the current science plan. You can see what modeling has in the current plan in Richard's talk, but then you can go into more details and we can talk about it later. So now if you go to the next slide. As I mentioned, the current plan will end in 2021, and the next plan that we are thinking about will start in 2022 to 2026. By law, we are supposed to implement, to develop and implement an IRPIC plan every 5 years. So that's why we're going through this process of thinking about what the next plan should be about. And we're starting quite early. 2022 is a bit away, but we are starting early so that we can get input from all of you as we think and start working on the plan. To be clear, we as part of the planning committee have not drafted or not put any thoughts, anything into writing. We are in the listening phase, and I want to emphasize that just in case it's not that obvious. So the plan provides goals for collaboration teams to address that will advance understanding, solutions, and policies in the Arctic. So if we go on to the next slide. These are a few basic facts for everyone to keep in mind when we think about the next plan. So first and foremost, the plan is supposed to be responsive to the mission of the different federal agencies. The plan, the Arctic Research Plan, is also considered a federal document, and the research plan's focus and research should be enhanced through cooperation between federal agencies. So it does not necessarily mean that everything that all the federal agencies do will be incorporated into the plan, but we are looking for places where different agencies can interact together to enhance our understanding of the Arctic. The plan to date has been primarily focused on basic research, but into the next plan, we could include applied research, and we're also open to including more from the social science field. A lot of comments have come up regarding that there isn't sufficient input, sufficient focus regarding social science in the current plan. So that's something that we are considering. Now, if we go on to the next slide. Thanks, Anne, for doing this. So this is a schematic or the timeline of what the development process is. First and foremost, we're trying to be as open so that we can get input from all of you. In fall of 2019, we got permission from the principals of the IARPIC group to go ahead and work on the next plan. And so there was an planning steering group that was developed. And as part of the planning group, which I'm also a part of, we have two subgroups, one that focuses more on engagement with the outside community, and another that is focusing on an upcoming workshop where we will get input from the community to work on things. Right now, there is a Federal Register notice that we have put out there for getting input from everybody. The federal agencies have a different way of contributing their input, but the Federal Register notice is open to the whole community to provide their input. We have many listening sessions and public webinars, and this is also one. Today's session is one of them. And then there's going to be a workshop, and in early winter of this year, we will start working on the goals and the drivers of the plan based on the input that we get. And then we look for approval from the principals of IARPIC we give them an opportunity, or they provide guidance on the drivers and goals. And then we start, and it's only then that we start the writing process. And once we go through a writing process and a draft is developed, again, there is an opportunity for the community to provide input. And it will go through iterations, and we hope that it will be finally cleared in the winter of 2021 so that it can be implemented in 2022. So as you can see, this is a detailed process, and that is why we are looking for input from everybody. Next slide, please. Okay, so this is about the Federal Register notice. We actually have 1 month from today to get input, and you have 1 month to provide input into the IARPIC plan. You get to provide input regarding the content of the plan, the overarching science drivers, the 4 drivers that I mentioned, and then the collaboration teams and the goals and the performance elements. And you also need to provide input regarding the organization of the plan. Do you like the way a collaboration team corresponds to a goal? And those are, so if you have better ways, or if you want to suggest other ways of improving the plan, please go ahead and suggest that. Next slide. So there are many ways you can provide input. One is through the Federal Register notice, and that is quite an important part. The other is that you can email the IARTIC plan at NSF email address that's there. There is also an online form available. Actually, if you go to the IARTIC webpage, you can get a link for that. You can also direct message the IARTIC through the IARTIC collaboration Facebook page. Public webinars and meetings like today are ways that you can provide input, but we also would very much like your individual comments through the Federal Register notice. In addition to all this, I'm aware, I mean, I've heard people calling in from NASA, from the CSM group, from DOE. All of you will have strategic plans that you have developed that have a component of the Arctic in it. Please do share your strategic plans so that while working on the next report, we have that input to work with. And all this information can also be found on the website. So I think this is the last slide, or there's one more. Can you? Yes. So once we started as part of the IARPIC steering group, while planning for this next phase, once we started that plan, we have a plan development director, Nikush Carlo. She's she's one person who welcomes new ideas. So you can also email her, and many of you also know Meredith, who has been a part of the IARPIC activities helping us. So feel free to email her also. So this is just the overview about the IARPIC plan, and I can take a few questions now, or we can wait for Richard's presentation also and then take questions together.
Yeah,
thank you.
I would recommend just to save on some time to go over to Richard's so we can get more of an idea what the modeling world looks like for you guys, and then we can go into the discussion section.
Okay, thanks. Can you hear me?
Yeah.
And can you see my slide?
Yes.
Very good. Okay, so just quickly, as Renu outlined, so there is an Arctic research plan, and so it's organized into performance elements to understand how the various agencies are making progress on Arctic research, and these performance elements are organized in the plan under objectives. So each of these performance elements are then assigned to the various collaborative teams. So we are the modeling sub-team. We are a sub-team along with the data sub-team and the observing sub-team under a collaborative team known as environmental intelligence. And so I believe when the 2017 to 2021 Arctic research plan was formulated, the idea was that these three groups would somehow provide a fusion for understanding various data and modeling and observational issues associated with the Arctic. But first of all, right now I'm going to give an overview of what the performance elements are that are assigned to the modeling sub-team. They're organized under two objectives. The first one is oops, I'm on the wrong slide. Sorry. The first one is understanding through modeling. So an understanding of Arctic processes and understanding of the feedbacks and interactions that are associated with the various components of the Arctic climate system. The second research objective is to enhance predictive capabilities for timescales from sub-seasonal to decadal timescales, and for climate projection capabilities associated with, for example, the CMIP style Earth system model simulations as well. So then the specific 10 performance elements that were decided upon, and so these were essentially points that were emphasized when this meeting occurred, I guess, back in 2016, were as follows. So back then there was an interest in understanding Arctic and mid-latitude interaction, connections between the Arctic and global ocean circulation, understanding the various interactions between the Arctic climate systems, the oceans, sea ice, the land, and the atmosphere, interactions between clouds and aerosols, the effects of thermal forcing of sea ice, changes in ocean stratification, stratosphere-troposphere interactions, and also a survey of investigator-driven modeling projects. So those were the topics, the 4 topics that were considered under the understanding objective. And then under predictions and projections, there was the performance elements of developing very high resolution simulations for the Arctic, activities associated with CMIP6 for improving predictions and improving Earth system models, fostering interactions with the Arctic test bed. That's a NOAA activity for improving numerical weather prediction and NOAA modeling capabilities in the Arctic. The development of regional Arctic system models focused on improved resolution and process representation. The improvement of numerical reanalyses for the Arctic, and support of the ice sheet model intercomparison project. So that would be associated with Greenland. In addition to those 10 performance elements, and there are a lot of performance elements associated with the modeling subteam, there are other performance elements that are kind of peripherally related to modeling. So these are assigned to other collaborative teams within IARPIC. There's the performance element 2.3.2, which is for Arctic clouds and their interactions with aerosols to better understand those interactions. The forecasting and prediction of sea ice, the impact of Arctic land ice changes and the impacts on global sea level, permafrost processes, and everything that entails, hydrology, ecosystems, et cetera, and terrestrial and freshwater ecosystems. So this is a survey of meetings of the modeling subteam over the last, I guess, year or so. So essentially, as we've indicated here, the IARPIC and its various collaborative teams serve as a clearinghouse to try to identify progress that's being made by the various agencies on these various performance elements. The modeling subteam usually meets in collaboration with other collaborative teams. So for example, we had a meeting on the polar amplification model intercomparison project that was joint with the atmospheric collaboration team. So that's a general thing that we do, is we try to identify various things with other collaborative teams. And so that's a way for us to involve not only the modelers, but also the process people that are associated with those various collaborative teams. So now I'm going to go over some examples of some of the things that we've done as part of the modeling subteam over the last year. We've had a deep dive essentially in marine biogeochemistry in the Arctic. So we've been working closely with the Marine Ecosystems Collaboration Team to improve communication collaboration among the observational people and the modelers for Arctic biogeochemistry. So we've had 4 joint meetings over the last 2 years, I'd say. And the outcomes of that, there's been a white paper that's been published on needs and priorities associated with Arctic biogeochemistry research. And there is discussions of a IARPIC workshop dealing with this topic. So A second point here is tracking water masses in the Arctic Ocean. So in March 2020, we had a meeting that examined Eulerian and Lagrangian approaches to studying transport processes in the Arctic Ocean. And we had a few presentations on the pros and cons of those methods. And the various conclusions were that the Lagrangian method provides more computationally efficient, but does not adequately represent mixing or convection processes. And finally, we've tried to highlight all of the modeling or comparison projects that have been ongoing with CMIP6. And so we've had a series of meetings associated with the various modeling and comparison projects that are both related to CMIP6 and even Glacier MIP, which is not endorsed by CMIP6, but we also had a meeting associated with that. We had a meeting that also highlighted recent work that was associated with the FAMUS project in September of 2019. So we've tried to highlight each of those of the works and advances that are associated with these intercomparison projects. So for the remainder of the current Arctic research plan, we have plans for a few more meetings that would highlight modeling associated with Mosaic project, Arctic review again of Arctic seasonal sea ice prediction, a follow-up of the modeling and comparison projects, and of course the marine biogeochemistry workshop. The fifth point is that we're going to conduct a survey of Arctic modeling capabilities. This was a survey that was conducted associated with the previous plan, essentially to identify capabilities and performance associated with various modeling assets for the Arctic Ocean. Okay, so that's an overview of the modeling subteam and what we've been doing thus far. So some topics for discussion then for this listening meeting. So we tried to write down some questions here that could be considered by the listener, by the attendees here. So we've written them down. One of them would be I've listed off the topics that were looked at previously. What are some of the emerging modeling topics that should be included for the next 5-year Arctic research plan? Should the plan continue to work as it is with these performance elements and then essentially tracking these performance elements as they become involved, or should the plan have some more dynamic role? Should the performance elements be evaluated within the 5-year period, something like that? A key question that we would like some input on is whether the structure of IARPIC should be similar. Should the modeling subteam continue to be part of the environmental intelligence collaboration team? Is there a modeling, I guess we would call it a modeling culture that would necessitate a collaboration team in its own right for addressing issues associated with modeling? And how should modeling efforts be made more relevant to Indigenous Arctic communities? I think that's been on the radar since, certainly since the Arctic Futures 2050 workshop in Washington, DC, that the research community needs to be more accessible to the Indigenous communities. But the question is, to what extent should that occur? Should we also continue to focus on these science questions that are being posed? So with that, I'm going to stop sharing. So I'm not sure how well, NASA doesn't use Zoom. We use other capabilities, but I think based on what I've seen from other collaboration teams, I think if you can just speak up and if you wish to raise a comment associated with any of the questions that we've listed or any of the comments that we've made, or if you wish to type them into the group chat box, that would be good as well. Is that okay,
Yeah.
Ryan?
I was going to suggest that as well. And I'm happy, I'm going to keep track of the chat. So if anyone drops anything in the chat, I'll keep track of that.
This is John Walsh.
Maybe it's a good idea. Okay.
Go ahead, John.
Sorry, maybe it's a good idea to put the final slide up that
for reference with the 5 questions.
Okay, I can do that.
This
Go
is
ahead,
John
John.
Lawson. That was the slide I wanted to refer to as well. That last one with the 5, yeah, that one. With respect to the first and the 5 squares, a topic that bridges them nicely is extreme events in the Arctic. And then there's a whole variety of them. I mean, floods, high wind events, freezing rain, fires. That hasn't gotten much attention in a coordinated way among the modeling communities. But the extreme events definitely impact the indigenous communities. At some of our AMAP meetings, they've emerged as a topic that the community wants more, the native communities want more information on. The impacts of climate are highest through the extreme events. And I know that there is a lot of work going on. Marika's group has done quite a bit of work on extreme events recently, and so have some other groups, but it has not been coordinated. And I think that IARPC may well have a role in linking an emerging topic with the indigenous communities. If we look at the extreme events a little bit more, in a more coordinated way.
Thanks for that comment, John. If I could just follow up, do you think that extreme events should be lumped together? Should they be separated into various topics like terrestrial extreme events, sea ice extreme events? How should that be managed?
Good question. I don't have a silver bullet answer for it. Perhaps the terrestrial and marine separation might be one way to go, in the sense that the impacts on ecosystems can be, I think, looked at by different communities, the marine and terrestrial, but how we separate out the different types of extreme events, I'm not quite sure what would be optimal.
So this is Marika. So I agree with John. I think extremes in general is a really good topic, and it's very rich in terms of the modeling too. I mean, what kind of models are able to capture what kind of extreme events? What this balance between large ensembles versus high resolution. I mean, there's lots of complexity there that I think would be very worthy of a coordinated effort. I also want to throw into the mix just actionable science in general. So you have, relevance to indigenous Arctic communities, which I think is a piece of this actionable science. But I think actionable science is broader than that. And so I'd like to just note that we should be thinking about how we can use our models to inform decision-making in the Arctic more generally.
Can you give an example beyond indigenous?
So, I mean, oil spills in the Arctic, say, with enhanced increased shipping, how can our models be used to inform where oil might be distributed, what communities might be at risk, both indigenous communities and other communities, what that means for shipping in the Arctic and shipping regulations. I mean, that's just one example. I think we could think of many, many examples in that spirit, shipping in the Arctic in general, resource extraction. There's all sorts of terrestrial questions with infrastructure risk, and yeah. But I think in terms of the modeling context, how do we use our models, which have, look out at seasonal, interannual, multi-decadal timescales, to better inform those questions? Okay. And how do we work with those, those different stakeholder groups to actually manage that, to make our model predictions more useful?
That's great. I've just thought of another example now that I've got my mind locked in here, was some of the Arctic Collaborative teams have had recent meetings on harmful algal blooms. And at our last team leads meeting, there was some discussion about, how to make that data providable to Arctic communities and things like that. So I think that would be another example.
Yep, that'd be a great example. And things like fisheries, which is very relevant to Arctic change and sea ice change and things like that. So I think bringing in the biological and the biological modeling piece of it, and this sub-team is already moving in that direction with a lot of, marine biogeochemistry modeling activities, right? I think that could be a really nice emphasis for the next 5 years.
Okay, great, thanks.
So this is Vislav here. Can you hear me?
Yes.
I wanted to comment or have a little discussion about the sub-team structure, the green bullet on number 4 on your topics for discussion. First of all, I would like to find out from those who are more familiar why the modeling is a sub-team of the intelligence and it's not like the integrated interdisciplinary a team component. And I believe that in the previous science plan, not the current one, but the 5 years ago, whether this was at the regular team level or it was still sub-team. In my opinion, this reflects also to some degree a structure of IASC working groups where you have the disciplinary groups like atmosphere, cryosphere, and so forth, but they're still missing the integrated and the interdisciplinary component and perspective on all those disciplinary efforts, both modeling and observations. So I just bring it up as a point for discussion, and I feel strongly that the modeling team should not be hidden somewhere under some other team as a sub-team, but it should be actually a standalone, integrated team level effort.
Renu, can you provide a little bit more background as to how we got to where we are?
Well, in the previous plan, not the current plan, in the previous plan, we were a collaboration team in our own right. I guess as, just like we are doing this process now, as we went into the 2017 to 2022 plan, there was suggestion from people, from groups that maybe modeling could be, viewed as a sub-team, as part of an environmental intelligence team, and that got implemented that way. In some sense, I think, I do hear Vislav's point in the sense that I think that we are doing the same work as a collaboration team, and so calling us a sub-team may not be an ideal situation, but, it's in the name, but I think we've been operating as a collaboration team right now. This could change into the future if people want and if agencies see a need for it. So if you feel strongly about something like that, please make sure that you capture it in the Federal Register notice.
So this is Marika again, can I ask, how does this sub-team interact with the other collaboration teams? Because there's a sea ice collaboration team and an atmospheric collaboration team, et cetera, and they all, of course, have modeling aspects to them. And I know that, so that to me seems to be a complication, that some of the modeling things are being done within those other collaboration teams, but this sub-team is just focused on modeling. So could you explain a little bit how those things interact?
So maybe I'll take the first shot, and then Wilbert and Richard can talk about how we're operating. even I mean, in the current structure also, we acknowledge that modeling is a part of other teams, but we also, as part of modeling, have the ability and the capability of looking at interactions. We're looking at the Arctic system as a whole, and that is reflected in the way we've had our meetings so far. Most of our meetings were collaborative meetings with the atmospheric team when appropriate, or with the CI team, or we've had meetings on the topic of mosaic with both the atmosphere, CIs, and the modeling team coming together, and so on. So that's we've been interacting with other teams. We are looking at the whole perspective, while the CI team might be looking only at a particular aspect of it.
Wilbert, do you want to go ahead?
Wilbert? Mm-hmm.
I agree with that. So I think we have an integrative Earth system modeling perspective that maybe the individual collaboration teams do not have. They're focusing more on their own process modeling studies and things like that. I do think that going into the next phase, there might be room for an integrated Earth system modeling collaboration team to make it more official, basically what we've been doing all along, I think.
And this is Hailong. So I also advocate the moving the modeling sub-team to the team level. Maybe will be the functionally will be the same, but it definitely will increase the visibility of this team.
Can I say something? This is Mike Steele. Hi. So I find this this part of the conversation a little bit odd, frankly. I mean, what we're talking about here is that the modeling team acts as the mechanism for climate interdisciplinary, integration. The modeling team is, the answers that I've heard in the last few minutes are that the modeling team serves to integrate disciplines. And that's a little weird to me. I mean, of course, I can understand that answer, but if there is a need for interdisciplinary, integrated climate work, then there should be a team for that. And I don't know that it should necessarily be called the modeling team. And it seems to me that one of the key things that a modeling team should do is talk about modeling. And for instance, Richard gave us some examples of what the modeling teams have been doing. And one of them was something that I was listening in on, participated in, which was the, how should we do ocean tracer experiments, Lagrangian versus Eulerian. That's a good modeling team discussion. It's basically sort of the nuts and bolts of modeling. So that seemed like a good modeling thing, but I don't know. Those are my thoughts.
Mike, just to follow up, do you think that, for example, the MIP experiments, should those be covered by the modeling team, or should they be covered by, I don't know, for the example of the sea ice, the sea ice in your comparison project, should that be specifically the focus of the sea ice group?
Well, wait. I mean, MIP, the M in MIP is modeling, so it certainly should have modeling. I'm not objecting to the idea of a modeling team. I mean, I think it's a false dichotomy to say that, you should we have modeling separate, or should it be subsumed in a discipline? I mean, you can have both, basically. I mean, it's fine, so a MIP is about modeling, but a MIP that focuses on, I don't know, plants or something should have plant people involved, or CI should have CI's people involved. It can be both.
Dave here. I'm surprised, Mike, that you didn't say observations, but I mean, it sounds like it's a little bit of a slippery slope here that, if we say, well, the modeling team should be its own collaboration team, well, why not observations? Because observing is reaching across all the disciplines as well, and same with the data integration part of it. I mean, I think if I'm going to paraphrase Mike a bit, I think maybe this more interdisciplinary team, maybe you change the title of environmental intelligence and make it more of an interdisciplinary collaboration team, and then modeling, observations, and data integration are all sort of part of that underneath. So it's not really changing the fundamental structure. It's just, I think maybe just a name change that would be more representative.
Thanks, Dave.
Andrew Roberts here. I was wondering if I could address some other questions that are listed here were emerging modelling topics. One thing that I haven't seen a lot of in planning literature is addressing sea level rise in the Arctic. And from a modelling perspective, that requires quite a few developments: non-Business Ocean, ice shelves in the Antarctic, which are probably likely to affect sea level rise in the Arctic, and improvements in land hydrology. I'm wondering if that should be quite a high priority topic now, particularly because it affects the last question about affecting Indigenous communities.
I think that's pretty good. We have had a recent meeting with the coastal group, right, on modeling of coastal processes, essentially as effects of the effects of sea level rise. Is that right, Renaud? We've had a meeting on that recently.
Wilbert? I defer to Wilbert.
So you have the slide deck with our past meetings at hand, Richard. So we had this session on the interface project that both Andrew and Joel are part of. Was that the one that you're talking about, or?
That's what I was thinking.
Okay.
But that's very good. Thank you, Andrew.
Since there's a quiet space, I'll just add, it would be nice to see high-res MIP added to those MIPs that are being considered. That results from several groups are showing that there are large impacts for polar regions in global high-res simulations.
Okay. Are you aware of any studies that have focused on the Arctic using high-res MIP simulation?
At this stage, the studies that are being produced are including the Arctic and the Antarctic in them, but aren't specifically focused on them. But that's only because a lot of the simulations are only just being finished at the moment. That's the published work I'm talking about.
So Wilbert, I should say that while I'm in presentation mode, I'm unable to see the chat box.
I just wrote in the chat box that we're extending the time of our meeting a little bit to give us a little bit more time to collect some input from everyone, if people can stay longer.
So just to follow up on what Andrew brought up in terms of the land hydrology and the Arctic coastal issues, I think that overall, and that's from the modeling perspective, the land-ocean coupling in the coastal region and estuary is something that it's not adequately, if at all, represented in major climate models and many other regional models as well. So that might be a wording different or something, but the bottom line is that if you look at existing CMIP type activities or any other Arctic regional activities, the coupling between the ocean and land is actually very limited, if at all. I'm thinking about, for example, temperature signal warm water from the rivers is not accounted commonly, and the nutrients input from the rivers trucking all the way along the river and into the estuaries, into the coastal ocean, as well as representation of the coastal ocean dynamics, not only the ocean, but also the landfast ice, as well as the sediments, entrainment, and so forth.
Thank you, Wisla. If I may, I'm just going to go back to our current points here. And as another topic of interest, ask whether some of these questions are still relevant. Is it still important to highlight Arctic mid-latitude weather patterns? I think there's been several, papers that I've been reading several papers by Fife and co-authors suggesting that, perhaps these should be de-emphasized. There still seems to be a lot of interest in stratospheric tropospheric interactions associated with the Arctic. Are any of these other topics still relevant, or are they not relevant? Do you feel motivated to express an opinion on that?
Ocean stratification is definitely still relevant.
Okay.
The Arctic mid-latitude is also currently not reaching any consensus here within the science community. So I would argue that there's a lot of work to be done in the next 5 years as well.
Okay.
Yeah, and the interactions between clouds and aerosols is also still very relevant, especially with the increasing model resolutions and also possible local Arctic shipping. So this is more relevant, I think.
Thank you.
As a matter of interest, what's meant by very high resolution?
I mean, so people are, in terms of Earth system modeling, I guess the raster model, the resolution is still pretty the cutting edge resolution, but there's people start to do cloud modeling within the Arctic in support of the Mosaic and other DOE field campaigns, the combo and others.
Dave here. So I'm just noticing point 934 down there too. That I think the regional Arctic system models is still an important aspect of this, but also adding this idea of global models at higher resolution or regionally refined grids, I think is another piece to this. That certainly it's a direction we're moving.
Stretch grid.
Mm-hmm.
There is a 931, which is basically saying exactly that.
But not the regionally refined.
Global variable resolution.
Yeah.
Okay. The region. Mm-hmm.
I mean, I honestly think most of these are still relevant.
Yeah.
I don't think there are complex relationships between ice, ocean, land, atmosphere that we still don't understand. There are, Arctic mid-latitude interactions that we don't understand. So I don't know. I mean, I think it's very challenging to take anything from this list and remove it, except maybe CMIP 6, maybe now that's CMIP 7, but I mean, I think maybe some of those things could be made more general, like model development capabilities or model development activities to support intercomparison projects more generally, which will include CMIP 6, will include ISMIP or CMIP 7, ISMIP 7, SIMIP 7, etc. So, I don't know. I think it's.
Well, I might propose that could be a problem. I don't know what the goals here of these performance elements are, but if they just continue forever, I mean, is the goal to have a 5-year plan? We're at the end of the 5-year plan, you know, we're checking things off, like, you know, okay, that's done, let's do something new, or you know, yeah, what's the goal of these research objectives 9.2? Are we supposed to identify something and sort of solve it in 5 years, or they just continue forever?
Well, in answer to that, I think essentially we're simply tasked with showing whether there's been progress made in addressing these issues, not necessarily whether they're checked off or not, but whether you know, adequate focus has been made by the various agencies on these questions. But it's important for us to hear that, you know, these questions are still relevant.
I mean, I think in the understanding piece, it's more challenging because understanding is, you know, it's a continuous thing, right? It often isn't that you've fixed something. I think under the 9.3 predictions, projections, you know, there are some things to me that seem to be missing from this list. Like, oh, I guess there is a simulation capabilities. You just didn't highlight it in the blue. But, you know, using models to inform observations to enhance predictions. And that to me seems like an obvious thing that should be included. Data assimilation, which is on here. You know, theoretical studies of predictability. What is predictable? I mean, so using the models to inform the understanding of predictability. So it seems like the things on here are quite specific, or some of them are quite specific to, you know, certain MIPS and things that are kind of, we can check those boxes.
I guess I should speak up. I'm now part of the Sea Ice Prediction Network Phase 2, and we're having a meeting, like, you know, in a few days to further discuss the SIPN. We're going to write a little white paper for IARPIC about how, you know, about SIPN and about prediction and predictability. Sort of a, you know, a document about recommendations for the plan, and it's related to some things that Marika just said as well, you know, and but we're gonna, I think what we're gonna suggest is something about IARPIC and SIPN working to help foster and encourage more, prediction and predictability studies. Interdisciplinary, both disciplinary and interdisciplinary. So, I mean, I think we feel that IARPIC is a good way to, you know, a good method for collaboration and team building. And so, yeah, we're gonna, I mean, we don't have it yet, but that's what we're talking about.
Thanks for letting us know that, Mike. Are you working with the Sea Ice Collaborative team on that white paper?
I mean, we're not working with any of the IARPIC teams. We're working within SIPN to create a document that will submit to IARPIC.
I see. Okay.
Mm-hmm. We would very
John
much
Walsh.
like to have.
Could I add? Okay, it's John Walsh. Could I add one comment on this 9.3? Those are all nice objectives and I think worthy research areas, but the connection to users seems to be a little bit lacking. Perhaps if the identification of user needs in connection with some of those 9.3s could be worked into the narrative, that would really help. I think that would broaden the effort into the social sciences and the connections to the communities again, and other users, not just communities.
Mm-hmm. Mm-hmm.
Something I'd like to
John,
comment on.
can you
Just
suggest ways in which that connection can be made?
Well, I think engagement of some of the native organizations, groups in like the Inuit Circumpolar Council, some of the Alaska Native organizations, and other user groups, the fisheries industry, tourism industry, some of the industries that might benefit from improved predictions. Very often the science doesn't connect with exactly what the users could benefit from the most. And if we can make that connection more effectively, I think the modeling enterprise has more flags to wave.
So I agree with John wholeheartedly on this. I also think that it helps inform model development needs, and that's, so it feeds back into the model development activities. And if we understand what users need, that helps inform what we need to do, either improve in our model or new capabilities that we need to incorporate into our model. So
to me, this is kind of like a call for input from those communities that would benefit from, let's call it, climate services in the Arctic or prediction and projections in the Arctic. I don't see how, scientific community can go out, reach out to those communities and ask for input. IARCIC is a very good framework to actually have those agencies representing those other stakeholders, communities, to provide their expectations and needs and requirements for the modeling and prediction.
Yeah, I second that, Wisla. Yeah, I mean, we can have, individual people or native representatives, or but we can also have DC leaders of organizations who represent those communities, in an IARPIC framework, talking with the modelers and telling us, what is needed.
I wonder if a way that modelers could help approach this problem is we're very specific there at including simulation capabilities. Are there machine learning capabilities that can help make better sense of models for user groups? I'm thinking in particular of reinforcement learning algorithms or unsupervised learning.
Right, Andrew, I was gonna make similar comments, and also to kind of broaden the discussion that Marika and Mike had started earlier about predictability and predictions. I think there are opportunities here beyond just the assimilation capabilities to think about data-driven and observation-driven modeling that could help us also inform the development of process representations in models. And so I think representing that somehow may be combined with assimilation capabilities would be a useful addition here. And in general, I don't see, model data integration really brought out, and maybe there's a separate team for that, but trying to reach across to the observational community, both to be able to, very quickly and rapidly bring in those new observational data sets, even just for evaluating models, I think is a useful activity, but also for us to be able to take the modeling results and after evaluation kind of inform the observational communities about the kinds of measurements that need to be made or future campaigns that would be useful to advance our modeling capabilities.
Thanks, Forrest. Okay, it's 4:15. Renu, is that enough?
This is wonderful. I just unfortunately got reminded that I was late for another meeting, but this has been a wonderful set of comments that we got. I was just wondering about the idea of potentially starting a Google Doc so that we can collect more input regarding the science topics too as we go forward. maybe we'll do it now or a little later. But in the meantime, I'd encourage everyone to submit your comments to the Federal Register notice. I was wondering also, Wilbert was supposed to do a summary of this whole meeting, and unfortunately, I am late for another meeting, so I do have to rush out. I apologize about that, but Wilbert and Richard, thank you very much, and I hope you take it from here. Thanks.
Okay, thanks. I'd like to thank everyone for their very valuable comments here. This is exactly what we wanted. I don't know, Wilbert, if it's too much to ask for you to summarize everything that's gone through here. Do you want to do that?
So yeah, it's asked a lot because we've covered quite some ground, and this is really much appreciated, as Renu said. So this is exactly the kind of feedback that we're asking for. So we started off with a discussion about extreme events, that it might be a really good topic for us to focus on in the next 5 years. It would make it for a very natural connection between the modeling team and also indigenous communities and other stakeholders, fisheries and things like that. In terms of the sub-team structure of the modeling, the most comments are that it doesn't make sense at this point, that the modeling should have their own collaboration team acting like it, and our topic is pretty significant. But there's a little bit of confusion again on what the modeling team should look like. Should it be just kind of be an overarching team that connects the different collaboration teams, or supports different collaboration teams in their modeling efforts, or should it really be an integrated Earth system modeling activity by itself? But then Mike suggested that it wouldn't make sense to have the integrated aspect only be the modeling part. So that is something that we still need to think about a little bit. But then we also talked about prediction and predictability. Obviously, that is an aspect that only the modeling can address. So that may be something that we could take into account when we discuss further the state of the modeling team in the next, or the role of the modeling team in the next proposal. I guess that was most of the kind of a very brief summary of things that we covered. Is there any very important thing that I missed in this summary? Well, then if not, please keep your ideas coming. So we said we have the idea of putting together a kind of a white paper, also to submit to the IARPIC as the modeling sub-team. But please also feel free to submit your own ideas to that to the different ways that Remy outlined. But if you have some more ideas that you want to bring to our attention, then please don't hesitate to either comment in the comment box associated with this meeting, or to send them directly to us as the co-lead. All right, Andy, you want to close it out?
Yeah, I was just gonna say that the recording and the notes will be posted online probably early next week because we have the long weekend. And I included all of the links that Renew was showing in the notes, so you'll be able to see and access them all from there.
Our next meeting is July 23rd. The topic is Arctic refined modeling with Glenna Viadani from Los Alamos National Laboratory and Erica Rosa from Sandia National Laboratory. Okay. I think that's it. Thanks very much for everyone for meeting with us. And we'll see you next time. Thanks. Bye-bye.
Thanks.
Thank you, Richard.
Goodbye. Thank you.
All right.
Thanks.
Thanks, everybody.